Hello lovely people, what is up? Today we are solving Leetcode problem number 190, reverse bit. So we will be given a 32-bit integer which we have to reverse the bit and then return the integer. And we have to remember that this is 32-bit integer. Even if the number is small, internally it is represented using 32 bits. So our goal is to take the rightmost bit and place it at the leftmost position. And take the second bit and place it in the second from the left, and similarly all the numbers, all the bits. Basically, reverse the entire binary representation of the given integer. So now the question is, how do we access each bit one by one? So we use bitwise operators. To extract one bit, we shift the number right by I position and AND it with 1. This gives us the ith bit. For example, let's take the integer 4 and we represent 4 with 0, 0, 0. 3 sets of 8 zeros and then 1, 2, 3, 4, 5 zeros, 1, 0, 0. So only the third bit from the right, 0 indexed, third bit from the right is 1. So we can write an expression like bit is equal to n shifted I times and ANDed with 1. So when I is equal to 0, n will be so many zeros and then 1, 0, 0. Then we shift n right by 0, which is again the same number, and then we now AND it with 1. So 1, 0, 0 and 0, 0, 1 gives us 0. So the 0th bit is 0. Now when I is equal to 1, we move the given integer right by 1, that now it becomes 0, 1, 0, and now we AND it with 0, 0, 1. Now we can clearly see the answer is 0. So we can conclude that the second bit from the right is also 0. Now when I is equal to 2, we shift by 2, which converts 1, 0, 0 to 0, 0, 1. And when we AND it with 1, the answer is 1. So the third bit from the right is 1. So the second index bit is 1. And now we want to place this 1 valued bit in the position 31 minus I. Why 31? Because it's a 32-bit integer and the index starts from 0 to 31. So since we extracted I is equals to 2, we compute 31 minus 2, which is 29. So we shift it left by 29. So the new value will become 0, 0, 1, and then 1, 2, 3, 4, 5 zeros and 3 sets of 8 zeros to represent it in 32-bit integer value. So our result updation statement will look like result is equal to result OR of bit shifted to right 31 minus I times. So now that we have understood the intuition, let's look at the code. So first we initialize a result variable to 0, and then we loop through the entire 32 bits, like for I in range of 32. We extract the ith bit. So like we saw before, bit is equal to n shifted I times to the right and with 1. So we update the result flag. Result is equal to result OR of bit shifted left 31 minus I times. It is shifted left. I previously said right by mistake, so we shifted to the left to reverse it. And then we return result. Now if you try running this code should run in the most optimal time possible. The time and space complexity are both constant because we are constantly only iterating through 32 bits. So that is all for today. Hope you guys enjoyed today's video. See you in the next one. Bye bye.